What do you mean by correlation regression? So still it's echo sound, sir? No. So okay, no? Okay. So what do you mean by correlation regression? So correlation regression is nothing but it is the association between two variables, two continuous variables. What do you mean by continuous variables? Continuous variables take any numeric form. So such as, I can give examples such as height of a person, weight of a person, or blood pressure level and glucose level. These are all some of the examples of continuous variable. How can you determine this correlation? Correlation can be determined by the value called as Pearson coefficient value or. So this Pearson correlation value or determines the strength of the relation. How about the relationship between the two variables? Is it okay? Can you able to hear it properly? Audience, please respond.
Ma'am, no, ma'am. Even now it is still like that.
Sorry.
Audience, is it clear now?
Still going, ma'am.
Still echoing. Okay. Sugu sir.
Ma'am, it's still echoing, ma'am.
No.
Now sir.
Yes, ma'am, now also.
Subha sir. Sir, is it okay now?
Yes,
Ma'am,
ma'am.
just
Okay, thank you, sir. The Pearson coefficient value ranges from -1 to +1. Okay.
Ma'am, it's echoing.
Still, ma'am? Okay, I check, ma'am. I check.
Now it's better, I think.
Okay, let me start. So if R was, I told you that two important things you have to notice in this Pearson correlation coefficient. One is strength and direction. So how may be the relation? The two things we have to notice while talking about the relationship. One is strength and direction. Okay, the strength, the direction may be of two kinds. Okay, one is in positive direction and the other one is the negative direction. And strength means how far the relationship is strong and how far the relationship is weak. So which will determine this correlation coefficient, the value -1 to +1 will be telling about the direction, and it also infer about the strength of the relationship between the two variables. So whenever the correlation coefficient value is towards the positive side, then the value will be in between 0 to 1. So whenever the value ranges in between 0 to -1, then the relationship can be called as negative relationship. Okay, so two type of relationship. The value ranges from +1 to -1. If the value is in between 0 to -1, then the relationship can be called as negative correlation. And if it is in positive, value is positive, it can be called as positive correlation. So these are some of the values and what may be their relationship. If the correlation value is 1, then you can see a perfect positive correlation. Okay, if the value is 0, then we can say that there is no correlation between the variables. There is no relationship between the variables. So based on the values, you can give this direction as well as the like whether it is strong or whether the relationship is weak or everything you can able to infer through the values. So before going into the analysis part, the main thing which you have to keep it in your mind is the correlation analysis has got some basic assumption. So only after fulfilling this assumption, okay, your data should meet all this assumption. Only after fulfilling all this assumption, you can able to do the analysis. So what are those assumptions? Two variables or continuous variables. So I already told you continuous variables are nothing but it will be like a numeric form. Okay, like weight, height. These are all some of the examples. It should take a numeric form. Then two variables are linear. Third important assumption is data should be distributed normally. So what do you mean by data should be distributed normally? So all the observation should cluster around the mean. So all the observation, most of the observation, the 68% of the data should fall within the one standard deviation. Okay, then 95%, and after that the last one 99.7% of the data. So all the data points should cluster around this mean. Okay, then that data can be called as normally distributed data. So what do you mean by two variables or linear? What do you mean by two variables or linear? So when you plot the x variables as well as the y variables, the data should be arranged in such a way that the data can able to get some straight line. Okay, so the data points which are drawn through the variables, okay, x variable and y variable, should get along the straight lines. Then that two variables can be called as linear. The variables are linear to each other. So if you plot it on the graph, the data points should arrange in a form that it should get along the straight line. Okay, I will be discussing about what is that straight line in the coming slides. Okay, so for correlation analysis study, you have to frame the hypothesis. Okay, the hypothesis, null hypothesis, is there is no significant linear relationship between hours of study. For this analysis, I have taken two variables. One is hours of study and the exam score. So these two variables are continuous variables. Okay, the exam score here is the dependent variable. The hours of study is the independent variable. So what may be the scores the student will get based on the hours they are spending for their studies. So I have created the hypothesis for doing the analysis, and through the analysis I'm going to prove the hypothesis. Okay, now we can go to SPSS. Participant can go to SPSS. Okay, you can upload the data. Kindly upload the correlation data, which I have shared with you earlier. Okay, so two variables are here. One is dependent variable, that is exam score, and the other one is hours of study, which is the independent variable. Now let's start the analysis. So basically we have three assumptions. So we have to fulfill that assumption. So one of the assumption is already fulfilled. Already we have met, that is nothing but the two variables or continuous variables. And now going to the second assumption. Okay, so whether the data are linear, whether the variables are linear, we can go to. So go to graph. Participant, kindly note down the path for checking the linearity. Graph chart builder. Okay. So in the gallery box, you have to select scatter dot and drag it and place it on the chart preview. Place it on the chart preview. And you have to place the dependent variable. Place the dependent variable, drag it and place it in the y-axis. And hours of study, independent variable, in x-axis. So for finding out the linear, whether the variables are linear. Okay, exam score. Okay, after placing it, click OK. Okay, are you getting this output? Participant can respond through chat box. Okay, now you have to double click it to check the linearity. Okay, so we have to going to check it. So in the menu bar, you have to click add a reference line from equation. Okay.
Ma'am, we couldn't follow that graph. Please repeat it.
Okay. Okay, I'll tell you one more time. Okay. Go to graph, chart builder. Okay. Now select the scatter dot in the gallery. Okay, first one, drag it and place it in chart preview. Exam score, which is the dependent variable.
Screen
Ma'am, that screen is not visible, ma'am.
Okay. I like.
Excuse me, ma'am, please.
Graph, chart builder. Okay. Are you getting it? Please follow it.
Practice data, ma'am.
Not practice data, other data, normal data. So other one which I have mentioned, right? That one. Okay, from the gallery, select the scattered box. Okay, already I have selected and drag it and place it here. And then exam score in y-axis, hours of study in x-axis, and okay. Okay, you will get this outcome. Can you able to see the outcome?
Yes, ma'am.
Okay. This will be the scatter plot which you will be getting, and you are going to draw the vertical equation line, okay, regression line, and check the linearity. For that, you have to double click. Okay. And from the menu bar, select the add a reference line from equation. Okay. So now it is clear. You can able to draw a straight line. So in this data point. Okay. So the variables are linear. So that's one of our assumption. We have met one of our assumption. And the next one, okay, going to SPSS again. We are going to check the last one. Okay. Analyze descriptive statistics. Explore. So move the both variables in the dependent list. So kindly follow it, please. Then click statistics. So check off descriptive, and continue. Then click the plot, uncheck stem and leaf, then check off normative plot with test. Okay, and then give OK. Sharipap. Okay. So now moving to the outcome. Okay. So we are going to check the normality and moving to the outcome. Let me share the outcome. Okay, are you getting this? Test of normality. Audience, kindly reply through chat box. Can you able to see it clearly? Okay, it's not clearly visible. Kindly give me a second. Now is it clear? Can you able to see it clearly? Okay. So for testing the normality, you have to check this box, okay? Test of normality. So you have two tests. One is Gulmogrov-Simbenev and the other one is Shapiro-Wilk, okay? So since the sample size is less than 50, we have to check the result of Shapiro-Wilk test, significance level, okay? Here the value is below 0.05. Here the significance value of Shapiro-Wilk result is below 0.05. Okay, so we can say that the data are normally distributed. Okay, so all our assumption we have met. Now we can do the correlation test. Okay, so we have so far tested only the assumption, and now further we can do the correlation analysis. Audience, participant, kindly note the path. You have to go to SPSS. Okay, so analyze. Can you able to see? Analyze. Note the path. Analyze. Correlate. Bivariate. Okay. Analyze, correlate, bivariate. Move the variables. By default, you can see the tick mark here, Pearson. Okay. Now click OK. Okay, is it clear? Are you getting this? Can you able to see it clearly? Okay. So this is the major findings. Okay. So far we have analyzed only the assumptions. This is the major finding where you can able to identify the R value. Okay. So since where is the here the exam score? Okay. The value of the correlation between the hours of study and the exam score is 0.840, which is very close to 1. Okay, so there is a strong and positive correlation between the hours of study and the exam score. And the other part of result is significance. So for how will you find out the significance? Because we have already framed the hypothesis. Okay, there is no significant relationship between the independent variable and the dependent variable is the null hypothesis. And alternative hypothesis is there is a significant difference between the dependent variable and independent variable. Since the p-value is less than 0.05, here we can reject the null hypothesis. So I'll go to the slide and show you the interpretation for this correlation analysis. Okay, this is the hypothesis which we have framed, and through our SPSS analysis, we are going to find whether we have to accept the null hypothesis or reject the null hypothesis. So the correlation coefficient value, R value is 0.840, where we can infer that there is a strong relationship between the two variables. Okay, so in the interpretation part, you can write like this: the correlation of coefficient for hours of study and the exam score is 0.840. So the correlation coefficient R values ranges between -1 to +1. So here you all know that if it is very close to 1, then it can be called as a perfect positive correlation. Our outcome shows R is 0.840, hence high positive correlation between the variables. Okay, this is one part of result, and the other one which we are going to interpret is about the significance. Okay, so significance, since p value is less than 0.05, null hypothesis is rejected at 5% level. Hence, there is a highly significant relationship between the exam scores and hours of study. Okay, so now let's move to the next part of our session, simple linear regression. So what is the difference between correlation analysis and simple linear regression? Correlation analysis will be, you can able to you identify whether there is a relationship between the two variables, whereas in simple linear regression, one of the main objective is you can able to identify the relationship between two variables as well as how the independent variable will can able to predict about the dependent variable. Okay, here prediction is possible. Here cause and effect is possible. But in correlation, you cannot able to study that prediction, or otherwise called as cause and effect. In simple linear regression, you can able to study the relationship between two variables as well as the impact of one variable, that is independent variable, on the other variable. Okay, so that is called as simple linear regression. This can be called as a simple linear regression because you are going to use only one independent variable and one dependent variable. So here also both the variables are continuous variables. Okay. So one more thing, in simple linear regression, the relationship can be expressed through a straight line. Okay, that is one important point you have to make note of it. The relationship between two variables can be expressed through straight line. The equation for the straight line is y is equal to beta naught plus beta 1 into x. Okay, so y is the dependent variable here, where you have to predict the value of y through the x coefficient of x. Okay, with the help of coefficient of x, you can able to predict the value of y. So y is the dependent variable, x is the independent variable, b1 is the regression coefficient. Okay, the b1 is the regression coefficient. So what you can identify through this b1, how much y changes for each unit of x changes. Okay, how much y will be changing for the each unit of x changes. So b naught is the constant. Okay, so this is the regression line. This is the regression line, and this is the regression equation. Okay, so here also we have some assumption. Okay, you have to fulfill this assumption, then only you can go for further analysis. So the first assumption is something similar to the earlier correlation analysis study. So the two variables should be linear to each other. Then residual values are independent. So otherwise you can call it as there should not be no autocorrelation. So how will you find out this no autocorrelation, whether there is the residual values are highly correlated or not? By means of Durbin-Watson. And then multicollinearity. There should not be any multicollinearity, and you should have the residual should have a homozygosity behavior, and the values of residuals are normally distributed. These are all some of the assumptions. Okay, so linear relationship, you know. So whenever you plot the variables, data points, x variable and data point of x variable and y variable, it should get along the straight line. Then the two variables can be called as linear. Okay, so that is one assumption. And residual, you should know about the residual. So whenever you draw the equation line, regression line, okay, the distance between the data point and the regression line can be called as residuals. The black line can be called as the regression line, and the vertical red line is the residuals. Okay, so when your data model can be called as a best fit, so whenever the distance between the residuals and the regression value were very close to each other. Okay, whenever the data point and the regression line are very close to each other, then you can call that regression line as the best model, best fit model. Okay, so this can be called as regression line. Okay, the vertical distance between the model and the data point can be called as residuals. So why am I explaining this? Because in the assumption, you can able to see the word residual. Okay, so residual is nothing but the distance between the data point and the regression line. So the SPSS will do so many various trial and error method, and it will find out which regression equation is the best fitted in that data point. Okay, so this is not best fitting. This is also not best fitting. Here, when you say look into this topmost picture, you can able to see some straight line where most of the data points are very nearby to that regression line. Okay, so this residual points should be very near to the regression line. Sorry. Okay, the next one is the residuals are normally plotted. For this, you have to do probability plot. Okay, so while doing the analysis, SPS analysis, I will be telling you. So, okay, so this kind of image you should get. Okay, if you do that analysis, you will get by means of this normal probability test, you can able to test this assumption, whether your data has met the assumption or not, by making use of normality probability plot test. So through this, you can able to see, you can able to tell whether the residuals are normally distributed. And the third assumption is multicollinearity. What do you mean by multicollinearity? So multicollinearity is nothing but you have in this analysis, you have some independent values. Here, there is only one independent value. But when you study, when you are about to do the analysis for multiple regression analysis, there will be more independent variables. Okay, so in that case, the independent variables should not be highly correlated. If the independence variable are highly correlated, then it will pollute it will give the same information to the dependent variable. Then the prediction will not be accurate. So why we want to do the prediction? Because we want to do the prediction only to get the accurate result. If the independent variables are highly correlated, then there will be multicollinearity. Okay, so how you can check whether there is a more multicollinearity or not? By means of VIF, okay, variable inflation factor and tolerance score. Okay, the VIF score should be below 10 and the tolerance score should be above 0.2. If your analysis result is in this limit, then we can come to conclusion there is no multicollinearity. Then assumption 4. So assumption 4, I already told you, there should not be any autocorrelation. It is something similar to multicollinearity. Multicollinearity, we are discussing about independent variables correlation. Independent variable correlation. The independent variable should not be highly correlated. Similarly, the residuals should not be highly correlated. So if it is highly correlated, then you cannot able to come to best solution. You cannot able to give the accurate prediction of Y. So in order to get the accurate prediction of Y, so there should not be any autocorrelation. So how can you able to identify whether there is an autocorrelation in the data? By means of Durbin-Watson test. What should be the value? The value should be in the range between 1 to 3. Okay, it should be if it is below 1 or if it is above 1, then you can interpret that there is autocorrelation is there. Then you cannot able to do this analysis, linear regression. Okay, the last one assumption is heterozygosity. The heterozygosity is nothing but the residuals now while plotting the data points. While plotting the data points, it should not form any pattern. You should not able to see any this kind of pattern. Okay, it should be randomly arranged. It should be randomly arranged. Okay, so if you can able to see the this kind of pattern, again the prediction will not be accurate. So this kind of the residual arrangement should be in a random fashion. It should be arranged in a random fashion. So these are basically the 5 basic assumptions. So after fulfilling this assumption, you have to go to the analysis part. Okay, let us go to the analysis part. So we have discussed about what are the assumptions. So based on this assumption, we are going to test our data. After testing the data, we are going to interpret the Y value with the help of the X value and X coefficient value. Let us go to the SPSS package. Okay, data file. Kindly, you have to upload simple linear regression. Kindly upload simple linear regression. Kindly upload simple linear regression. Can you able to see? Can you able to see? Okay. Okay. Now we can go to the path, analyze regression, analyze regression, linear. Move the dependent variable scores, move the dependent variable scores in the dependent box and independent variable in the independent box. Statistics. So by default, you can see the tick mark in estimate and model fit. Now we have to test the collinearity. So click the collinearity diagnostics, then Durbin-Watson, and continue. And okay. Can you able to get this outcome? I'll share. Kindly give me a second, I'll share. Can you able to see clearly the outcome? Okay, here we have many outcomes. So you have to give focus on these 3 main part. Okay, one is model summary and the other one is ANOVA and coefficient. Model summary, ANOVA and coefficient. Are you getting this outcome? Participant, are you getting this outcome? Kindly respond through chat box. Okay, thank you so much. Okay, so this is the outcome. The same outcome I have pasted in my slide. So I will be explaining you through my slide. Okay, so this is the outcome which you have got by analyzing your data. Okay, here the R value is 0.705. So, which is very almost close to 1. So, so the relationship between the variable independent and dependent variable is positive. Okay, positive. There is a correlation, and it is a positive correlation. And the second one is R square and Durbin-Watson. These are the things which you are going to interpret. Okay, no need to bother about the other items. So in the model summary test, you are going to interpret about R square and Durbin-Watson, and in the ANOVA table, you're going to interpret about the significance, and the coefficient table, you have to look only the unstandardized coefficient and the collinearity value, collinearity statistics value, this tolerance value and VIF value. Okay. So these are the outcome of our assumption test. Okay, so here linearity we have met for this data. SLR, in order to analyze SLR, the variable should be linear. So our outcome, through the outcome, you can able to see draw a straight line in this data variables. Okay, so the data, both the variables are linear. Okay, or in linear, and the histogram plot you can able to see, and the normality, probability plot. The data points, most of the data points are along the line, or it is on the line. Okay, so the regression, the residuals are normally distributed. You can come to a conclusion that the residuals are normally distributed. In the histogram chart, you can able to see the bell-shaped diagram, symmetrical bell-shaped diagram, and the normal probability plot. That most of the data points are along the straight line or on the straight line. So where you can conclude or infer that the residuals are normally distributed. And heterosidacity, I told you, there should not be any funnel pattern. Here, since the data set, you have less than 50 variables, you cannot able to clearly see any kind of pattern here. Okay, but you can see the data set or data points are randomly scattered here. Okay, so our third assumption, there is no heterosidacity. It is our data is showing some homozydacity behavior. Okay, so now coming to the major part. So I told you 3 parts is very important. One is model summary. Okay, in the model summary, you are going to interpret this R value and the R square value in the model summary. Okay, so R value, what I told you. So if the R value, if it is greater than 0.4, if it is greater than 0.4, it's well and good. You can take for further analysis. Okay, so because there is a very good correlation between the 2 variables. So in this case, in this study here, the value is more than 0.4. So which is quite good. And while seeing this value, Durbin-Watson value, why we want to see the Durbin-Watson value? Because we want to see whether the residuals are independent, whether there is no autocorrelation, whether the residuals are independent, whether there is no correlation between the residual values. For this, you need to check the Durbin-Watson value. So Durbin-Watson value I already told you, it should between 1 to 3. If it is between 1 to 3, then it is okay. The residuals are normally, or the residuals are independent to each other, and it's not highly correlated. Okay, here in the given study, the residual value, you can see 1.8, which is in between 1 to 3. Okay, so we have met this assumption, almost all the assumptions. Okay, and coming to the model and coming to the next one. Okay, model summary is okay. And coming to the next part, okay, which part is that? ANOVA table. So in order to check the ANOVA table, you have to frame some hypothesis. The null hypothesis is the regression model. So you are going to create some regression model here. Regression line you are going to create with the help of this SPSS tool. And you are going to analyze, or you are going to see whether the model is perfect or not. Okay, whether the model perfectly fit the data or not. How will you be able to see? Through the result, through the ANOVA table result. You can able to see whether the regression line which you have analyzed through your result is perfectly fitting the model. Okay, so how will you able to tell that? Through the significance value, Here the significance value is 0.001, which is less than 0.05. So you are going to reject the hypothesis at 5% level. So you are going to say that the regression model fits the data better. Why? Because the p-value is less than 0.05. And yeah, this is okay. But you can see this F value also. Okay, if the F value is greater than 2.5, then you can say the model perfectly fits the data better. But significant value is most important. If the significant value, if the P value is less than 0.05, automatically this F value will also be greater than 2.5. Okay, so this is how you should interpret. Since P value is less than 0.05, null hypothesis is rejected at 5% level. Okay, so out of the outcome, 3 major parts. One is model summary. In the model summary, what you have find out? We have find out the R value and R square value, and we have interpreted about this R value. And coming to the R square value, what is the meaning for this R square value? R square value usually range between 0 to 100%. Okay, it ranges between 0 to 100%. So what does that actually mean, the R square value? So it is this R square explain how much explains the degree, how the independent variable, what is the independent variable here? The independent variable is study hour. Okay, how the study hour explains the dependent variable score. Okay, how the study hour, which is the independent variable, explains about the dependent variable. Okay, in our case, 49.7% of the variation in the scores. Okay, 49.7% of the variation that happens, proportion of variation that happens in the dependent variable. Okay, that is in the score, is explained by the study time. So there is a connection, close correction that this study time can explain it clearly. Okay, so this R square will talk about how much, what degree this independent variable is explaining about the proportion of variation in the dependent variable. In our study, 49.7% of variation in the score is explained by the study time. So this is the interpretation for R square from this model sum. Okay, so two interpretation, you have to discuss about the R value, as well as you should discuss about the R square also. In the ANOVA table, you can discuss about the P value, and you can say whether your model fits the data or it is not perfectly fitting or not. And one more hypothesis you have to frame for this SLR. So that is, there is no statistical significant relationship between the X variable and Y variable. And there is a statistical relationship between the X variable and Y variable. Because so far we have tested only the model. We have not talked about the variables. So whether it is significantly related or not, we have not tested it. So how can you test that? So through this coefficient table. Through this coefficient table only, you are going to find out the value for this regression line. Okay, so you all know that for simple linear regression, the regression the equation is y is equal to beta naught plus beta 1 plus x. So beta naught is the constant, and beta 1 is the coefficient of x, right? So to find out the coefficient value, you have to, in the outcome, you have to look into the unstandardized coefficient. Okay, so constant value is here in the equation. Beta naught value is nothing but 73.434 is the beta naught constant value. And we also need to find about the coefficient value of x. So coefficient value of x, what is the x here? Study hours is the x, The coefficient value of x is nothing but 3.497. So we are simply substituting the value here, and we are going to find out predict the score. How can you predict the score? What may be the value of what may be the score the student can able to score? What may be the perfect exam score the student can able to get if he or she is spending a particular time? Okay, for example, if the student is spending 2 hours of time, what kind of mark he can score in that particular exam? So you can able to predict through your analysis. Okay, so through the analysis, you have already find out that the constant value, and you have also find out the coefficient value of x. So you have to simply substitute the values here. So if you substitute the, I'll go here. Okay, so 3.497 is the slope. 3.497 is the beta 1 value, that is slope of the line. Okay, what does this beta 1 tells? It tells that the changes in y value when 1 unit increases in x value. Okay, so how the changes happen in y whenever the changes happens in x? How much unit changes in x is x, and how it is affecting the y. Okay, so in our example, when the study hour increases to 1 hour, okay, whenever the study hour increases to 1 hour, the x, for example, 3.497, whenever the in the x value, if you are substituting 1, okay, so you the score will be to 3.49 units. Okay, so you can see some changes, you can see some increase in the score. How much score it increases? 3.49 units. If you study for 1 hour, you can your score increases by 3.49 units. Okay, so suppose when a student is studying for 3 hours, okay, assume that a student is studying for 3 hours, then what will you do? You have already find out the beta naught value through your analysis, and you have already know about your beta 1 value, isn't it? So simply you are going to substitute the value x value here 3, and you can able to predict the y value. Now you can able to predict how much a student can able to score if he or she is studying for 3 hours. Okay, so our answer is 383.925. Okay, so this is the example. This is a simple example. Okay, then we can go to multiple linear regression. Multiple linear regression is almost similar to simple linear regression. Only the difference is in simple linear regression, you are going to analyze whether there is a correlation between the dependent variable and independent variable, two continuous variables, or both are continuous variables. In multiple linear regression, you are going to identify whether there is a relationship between the independent variable and independent variable, where there will be more than two or more than two independent variables. Okay, it's not in simple linear, one variable, one independent and one dependent. Here, one dependent variable and two or more independent variable. Okay, and the equation goes like this. Okay, there y is equal to beta naught plus beta x. Here, because since you have various independent variable, so the equation goes like this: y is equal to dependent variable, beta naught is the intercept or constant, x1 is the first, here the x1, the equation x1 is the first independent variable, and x9 is the last independent variable. So beta 1 for x coefficient and beta n for xn coefficient. Okay, every independent will be having the coefficient, because only with the help of coefficient you can able to predict the y value. So here the equation also differs. So now we can move to the analysis part. Go to SPSS, and you have to upload the multiple linear regression data. Okay, can you able to get? Okay, so now we can move to the path, same path only. Whatever I have implemented for the previous analysis, no, the same path you have to follow here also. Okay, so analyze, regression, linear. Analyze, regression, linear. So move the dependent variable. What is the dependent variable here? Score. Okay, final exam score. So ours one because you have two or more than two. I have taken two independent variable. One is ours and preparatory examination. Okay, so move the dependent variable final exam square to the dependent box and independent variables to the independent box. Okay, and then statistics. So collinearity diagnostics, Durbin-Watson, continue, plot. Okay, here you have to note after plot, move the Z residuals, to Y and Z predictory variables to X. Okay, after plot, after clicking the plot, you can able to see Z residual and D residual. So this is nothing, we are going to check the homozygosity, no? For that, we are doing this, okay? And check of histogram and check of normal probability plot and continue. Are you following? Are you following? Continue. Okay, then click OK. Here also the same. Are you getting the outcome? Same outcome, nothing new. Okay, I told you, for simple linear regression, we have seen three major part of outcome. Here also that ANOVA table, coefficient table, okay, and model summary. So take all this thing. So these are the important results where we are going to interpret in our study. Okay, so I'm moving to the to my slide to discuss about those results. Okay, this is the outcome of our study. Okay, you all know that whenever the value of R is close to 1, you can easily interpret there is a positive correlation between the variables. Here we have independent variable and the dependent variables, 2 independent variable and 1 dependent variable. So they are highly correlated, and R square 0.71, 71% of independent variables are explaining about the proportion of variance in the dependent variable. Okay, and ANOVA table report here and multiple regression coefficient table analysis here. Now let's go to the interpretation. So in the R value, I told you, if the value of R is greater than 4, the value is 8.846, which is good. So Durbin-Watson, the value range should be 1 to 3, here 1.3. So our residual values are independent. So that's also okay. And then model summary. So 71 point of increase in your exam score is due to the increase in the study time. So 71 point of variation in exam score is explained by the independent variables. We have 2 independent variables, right? One is study time and the other one is a preparatory examination. How many preparatory examination you have taken and how many hours of study time, how many hours of study you have given for that test. So these 2 independent variables are highly explaining. Okay, 71.7% of variation in the exam score is explained by these 2 independent variables. So R square is also quite good. Okay, and ANOVA table. So significance value, you have to look into the significance value. Here, significance value is less than 0.05. So we are going to reject the null hypothesis, where we can say the model fits the data better. Okay, fits the data better. And unstandardized coefficient. What are the unstandardized coefficient for hours of study? 5.635. And preparatory examination, it is in negative, minus 0.584. Okay, it is in negative. And constant value for this study is 67.633. Okay, now the explanation part for interpretation part for this equation. So equation through this result outcome, you can able to see beta value, beta naught value, and x1 value, no, x1, what is our x1 variable here? Study hours. What is our x2 variable here? Preparatory examination, right? So coefficient of x1 is 5.635, that is beta 1. So whenever the study increases by 1, okay, study increases by 1 hour, the exam score increases by 5.635 unit. So according to this equation, we can able to tell that whenever you are studying for one hour, then automatically your score increases by 5.635 unit. Okay, then coming to this coefficient negative, the answer is in negative. What does this mean? So for each additional preparatory examination taken is associated with the decrease of 0.58 decrease of the score. How much mark, how much point it is decreasing? 0.584. Okay, so if you study for 1 hour, you can increase the mark, but there is no that much of significant relationship between the this preparatory exam and the examination score. Okay, so for example, a student that studies for 3 years and takes 2 preparatory exam, so he is expected to receive an exam score of 83.37. Okay, what does this mean? So you are simply substituting the value here. So what is the value of x1? The x1, the student is studying for 3 hours, so you are putting 3 here, and the student has taken 2 preparatory exam. And you are going to see whether how much impact it is going to give in his examination scores. Okay, so if he has spent for 3 hours and even if he has taken some preparatory exam, on the whole he is getting 83.37 scores. Okay, this is the overall understanding about this equation. Okay, then we can study about the this one. So what about the p value? Okay, this overall p value, this significant value is something different, where this significant value is something different because through the significant you can only able to tell whether the model fits the data or not. But the coefficient significant value, through this coefficient significant value, you can able to tell that which independent value is significantly impacted. There is a significant relationship, which independent variable. So this hours, the value for hours, the significant value for hours is 0.000, which is less than the p value. Okay, so we can say there is a significant relationship between the hours and the examination score. But while looking into the significant value of p value for preparatory exam, you can able to see 0.555. Okay, you can see able to see which is greater than 0.05. Then there is no relationship between the preparatory examination and the exam score. Okay, so here. So this is the p value for the explanatory variables. Since this value, this value 0.000, this value is greater than 1, we can conclude that hours of studied has a statistical significant relationship with exam score. 0.555 is not less than 0.05. So we cannot conclude that the number of preparatory exam taken has a significant relationship with the examination score. Okay, with this, I'm ending the session. Thank you, dear participant, for patiently listening my session. And if you have any doubt, you can ask me.
Participants, if you have any questions, you can raise the hand. I am happy to unmute you. And you have an option to unmute directly.
Yes, definitely we'll share. Anything you want to ask regarding the data or anything? Any doubt you have? These are all the parametric tests which I have discussed right now is the parametric test. There are also some alternative tests if your data is not met, if your data has not met the assumption. Okay, if your data is not normally distributed or if your data has not met the assumption, then there are some alternative tools for this. Okay, you can go for non-parametric test. Okay, for correlation analysis, you can go for Spearman correlation. And for simple linear correlation, if your data has not met the assumption, you can go for Kendall-Thayil test. Okay, so there are some other options are also available. So based on that, you can go for the other kind of test.
Thank you so much, Subha ma'am, for your wonderful session. We are enlightened with your elaborations. And dear participants, thank you so much for your active listening. And we will meet you on Monday for the 7th day of a national workshop on SPSS. On that day, the resource person was Dr. A.J. Excelsior, going to discuss something about the chi-square and other tests. So thank you so much, all the participants, and have a wonderful Sunday. We will meet you on Monday. Thank you so much. Have a great day.
Thank you, sir.